All right. Thank you, everybody. Title of the talk is GraphQL Exploitation, Secondary Context Attacks, and Business Logic Vulnerabilities. So real quick about me, I'm a senior staff security researcher at Sprocket Security. First, I want to thank Sprocket for the opportunity to come out here, and then everybody for coming to the talk. My name is Will Vandevanter. I've been in offensive security since about 2008. Talks at various conferences, Black Hat, DEF CON, and this is my second time at OWASP Global AppSec, so it's pretty exciting. Last time was Washington, D.C., and that is not a super old picture. I just cut my hair about a month ago, so I really did have long hair a couple months ago. All right, so most of the talk is going to be on GraphQL, but before we get there, I think we should lay a foundation around secondary context attacks. And before we get to that, talk a little bit about enterprise application design patterns. So a very common design pattern that I'm sure many people are familiar with is the backend for front-end design pattern in an enterprise app. In that case, you're going to have a web request coming into the backend for front-end, and then a second request is made to REST API or to a microservice. But the big important point here is that there's two different requests occurring. There's a request on the left coming from the user or from the client side, going to the BFF, and then on as a second request into like a trusted zone or into the enterprise application. If we were to drive into that as a little bit more of an example, let's say we have an initial REST API request, right? We're assessing an application, we're on the client side, the front end, and we see a request coming from our browser. And that's going to company.com, right? So that's the domain. The users API, so /API/users. And then there's this input parameter that's been added onto the end. So it can be a GUID in this case. When that request reaches the backend for front end, that second request is made, and it's modified. There's now a different request in the internal trusted zone. It's to user.microservice/users, and then that input parameter has been tacked onto the end, right? It's been added onto the end of the path in their second request. The request goes onto the data layer, and then that response is sent back out to the user. Sort of the short version of that might be if an initial request going to the domain, and then the second request from the backend for front end or from the proxy to the microservice. In a secondary context attack, we're modifying that controllable parameter, and that could be a post parameter, it could be as part of the path, or in this example, it's the ID parameter, and we're replacing that parameter with a path traversal followed by a different location that we want to access as the attacker. And so when that request reaches the backend for front end, it now becomes user.microservice/users/... account 12919 in this case, and then when fully path normalized, we as the attacker are now controlling, we're making the request to a completely different location. It was meant to go to /users, but because we put the path traversal, we've now tricked the BFF into requesting something else. And so potentially we profit in this case. We're able to access the secondary context, access another location internally. In this case, let's say it has an IDOR, and so we're beginning to pull out data that we just should not have access to. The first person I heard talk about this was Sam Curry in a blog post from 2020 called Hacking Starbucks and Accessing Nearly 100 Million Customer Records. And in it, he's talking about, it's a bug bounty context, but he does pretty much that exact attack. There's a Starbucks URL. I think it even has like /BFF in it. By modifying the input, he's able to trick it into going to a different location and accessing these 100 million customer records. The blog post is up here. He did a talk at KernelCon 2020 called Attacking Secondary Context Attacks in Web Applications. Again, excellent talk. I highly recommend it. Super good. He drives in more to examples and talking about the attack. 2023, he did a blog post called Leaked Secrets and Unlimited Miles, Hacking the Largest Airline and Hotel Rewards Platform. In it, the secondary context attack, again, plays a role through the middle, where they're accessing all of this data using a secondary context attack. In the bottom right, there's a QR code that just links to a gist, which has all of the references from the talk. And it's in here in a couple different times in case you miss it, so just so you have access to all the references. When I've been successful with this type of attack, one pattern that I've noticed is that authorization is often relaxed or removed between the backend for front end and the microservice. So if there's a scenario where, let's say, a JOT or an API key or a hard-coded password is placed in at the proxy, and then that request makes to the microservice, it just absolutely opens the door to a secondary context attack. And it's not really to like dunk on developers or security architects. In my observation, I think part of the way this happens is different dev teams are responsible often for different microservices. So you may have one dev team on payment service, another dev team on product service, and they have completely different threat models. So as it's coming into the BFF, maybe a request to the product service doesn't need an authorization header, or excuse me, it doesn't require it, but it's added in order to make everything in product service accessible. However, if we can modify where the BFF is requesting from, we also inherit that authorization header as the attacker. And so instead, let's say we hit the order service, the payment service, and we gain access to additional data. So it's kind of a key component for, if this is in place, it usually really opens the door to a secondary context attack. If you've tested a lot of GraphQL or you're familiar with GraphQL, you probably see where this is going, right? Like it's a very common design pattern in GraphQL to have a client on the left, make a request to the GraphQL server. That request then goes onto a REST API and then fetches from a database. It's like literally what we were just talking about. There we go. So in that case, if we have initial input where the primary context is improperly handled, right? So the primary context being at the GraphQL API or GraphQL server is improperly handled, it leads to a secondary context attack. So that's going to open the door for it. All right, so that was like a few minutes setting up the base, right? We talked about secondary context attacks a little bit. We've laid the foundation, and now we're more getting into GraphQL. So I guess quick like nodding of heads. Have people heard of a secondary context attack before? Is there? Yeah, so I see people, yeah. So it's not a hugely talked about vulnerability class in my opinion, but it is very powerful when it works. And that's going to be kind of the focus for the rest of the presentation. So for this real world example, I was on an assessment. I was identifying GraphQL servers. There was no introspection enabled on this GraphQL server or GraphQL API. They didn't have suggestions, so you couldn't get suggested objects out of it. But what it did have was an information disclosure on a validation failure. So on the left, I've queried for the object like client, and on the right, it's like, hey, actually, you need subtypes in here, and you also need input as part of that. So that's sort of this like initial jumping off point, right? We can force a validation error from this GraphQL server. From there, taking a dictionary of like common objects, sub-objects, and brute forcing on them, and these interesting errors started appearing in that it would always disclose the backend host that it was requesting from. And again, if you tested GraphQL, you've probably seen this before. And it would be something like, in this case, if I search on context, it has an error case where it would be like, hey, API v1 context, and it would tell you all of the get parameters, tell all of the information, but just that there was an internal server error there. Eventually, keep brute forcing objects, and one turns up to show that it goes to API v1 query, and it's clearly within the parameters. It allows you to specify a table and the SQL query that you want. Now, this is pretty exciting. This seems like, okay, now if I can control this, I can probably do SQL injection. The problem is on the left is there's no input to this. It's just simply contact, or excuse me, in this case, contract. And so I can't really control anything. So anyway, make a note, save it for later. At the same time, starting to find secondary context opportunities in the GraphQL server. So seeing something like the query contact, which requires input, and putting in a contact ID of like not real ID, I can see within the error response that that's being tacked onto the path. So if we remember back a few slides, now we know we can control the path of where it's going to. Testing a little further, adding in something like /test shows that it's actually jumping up a directory, and so it's going to API v1 test. And so this pretty much confirms there's a secondary context opportunity, at least the ability to control which REST API endpoint we're targeting. So combining those things together, the final exploit ended up being adding in a contact ID of .. API v1 query, and then a blind SQL injection. So you're taking that idea of having found the SQL query, which wasn't controllable, and now using it through the secondary context attack to call it in order to make the SQL injection. And it turned out to be super impactful. I could query against this database, a critical finding. One sort of subtle thing in this is that it needs to be a blind injection, because if there's a 200 response from the API server on the back end, it's going to get swallowed up in the GraphQL response. It's going to expect to see, in this case, a contact. It's not going to see a contact, so it's just going to give you nothing. But we can use timing attacks. So we can blindly inject this part of this GraphQL query, and that's what I was able to do and begin to pull out data. Does that make sense a little bit? So combining those two vulnerabilities together. I always appreciate, like in a talk, when somebody talks about the ways they failed. So I'll just give, like in that case, frame it in sort of like a methodology review of the ways that things that didn't work along the way. So at first, I identified GraphQL server on the external engagement. And one of like the tools that I'll use or techniques is a post request with a malformed query. And I'll spray that across like a large set of hosts. And the reason is because many GraphQL servers will be very verbose in terms of telling you like you have an incorrect query or a validation error. That's as opposed to some of the techniques will be like sending introspection queries or certain other types of queries that may not indicate that you have a GraphQL server. So I use this, identify my fingerprint was I did a post request with the malformed query, found the GraphQL server. Typically, I'll check for Apollo Playground or GraphQL UI endpoint. In this case, there was none. As I said, introspection query failed, so I couldn't get the schema in that way. I think it's pretty common, if you guys do a lot of GraphQL testing, to do like a JavaScript review. It's really common in single-page applications to hard code queries, fragments, mutations, components of the schema into JavaScript that's loaded into the client side. Once we find that, then we can figure out some of the schema in that way. So like this is a screenshot from JuiceWeasel, which is a popular tool, but also like JSluice can do it. If you're using Burp Suite bchecks, it can pick up on it as well. So there's no JavaScript. It's just a simple HTTP endpoint, so that didn't help me. As I mentioned, suggestion wasn't enabled. And so if people, I'm sure many people know this, but in some GraphQL server instances, you can take a guess at an object. So you can say query with the word banana. And it'll be like, no, actually, did you mean building? And you're like, OK, sure. Yeah, that's what I was looking for. And so you can fill out a schema in that way. A really popular tool is clairvoyance, if you've used it before. And that will automate the process of taking guesses and reading the suggestions to determine the schema. As I said, this didn't work as well. There's only validation errors, and that was the step in the story of moving towards brute forcing against the GraphQL API. And I guess a quick side note, I'll almost always run clairvoyance through a proxy, because even when it fails, it can pick up on GraphQL validation errors, and then it's like saved within Burp Suite or Kaido or whatever you're using. So at that point, now I know I have GraphQL validation, doing the brute forcing, and this is where we came into the story, mapping out remote REST API endpoints, finding REST API endpoints with the arbitrary SQL query was a big part of it, identifying that secondary context stack around the same time as we're brute forcing, and then combining those together for the final payload. So let's do another example. This is a completely different application, enterprise app. It was single sign-on, so you could create an account, and there was like some pretty powerful data once you created an account and associated it with different things. And as I was testing the application, I could see like these GraphQL queries that would be like view your private account data using a get account by ID query. So for example, it would have like on the left would be like an example one. It would have an account ID, which is a GUID. And then it would have this input as part of it, and it would return back the account information. So pretty standard stuff. This was part of the request. I think like many of you, one thing I'll test out is I won't necessarily go to a payload, but go to unexpected input. So in this case, the expected input was like a GUID, so just putting a string of like fake UUID. again, returned an interesting response. So in this case, it was 404 not found, microservice/API/me accounts, and then we can see at this point that that value is tacked onto the end of the path. So I have the potential that I can control which REST API endpoint this server is going to. So next, try out a simple path traversal payload. And again, now it's confirmed. We can definitely control it by putting .. /test. There's no longer an accounts component to the backend REST API, which means that it's jumping up a directory when fully path normalized. At the same time, creating like many of you again, probably create a second account. So with user 1 trying out user 2's account ID with the account directly, also gives a 404. And I think it might be a little subtle, but it's because it's in API/me/accounts and then adding it in. So there's no way this would ever work because user 2's accounts are not going to be part of my account as user 1. So the final payload ended up being, had to find a GUID leak on another part of the site, which was not a big deal. Found that, and then it becomes .. user 2's account/accounts/GUID. Now you can access anybody's data at all. A couple points I would call out from here is one, finding the UUID leak. It's probably my favorite low severity finding. Like once I find those, it's so valuable because I think there can be a misconception around IDORs where if you use a UUID, then you're perfectly safe. And it's really not true. There has to be like secondary validation or to make sure that that can't be accessed. Second part of that, I would say, is that we can tell that the authorization header is hard-coded in at the BFF because there should never be a scenario with my authorization where I can access somebody else's account data. So we know that by doing the path traversal and still being able to access other people's accounts, we have carte blanche that we can access anybody's account at that point. So those were two of the ways that got paired together. And again, kind of makes sense, right? We're taking two different vulnerabilities and we're stitching them together with that secondary context. If you've done a lot of GraphQL, one thing that might come to mind is like GraphQL requires strongly typed input, right? They call it scalar types. And there's 5 default scalar types. There's integer, float, Boolean, string, and ID. And I would sort of make the argument, and the documentation makes it as well, that there are basically like less restricted GraphQL scalars. So those are the default. You can add on to it, but of the default, string and ID both require input validation. So out of the box, they're not going to be type safe. So for example, let's say that we have an input of string. Both of these are valid string inputs, right? Like a GUID is a valid string input, but so is a path traversal exploit. And then the more important one is probably ID. So I mentioned of the 5, the 5th one is ID, which according to the documentation serializes the same as string. It just signifies that it's not intended to be human readable. So an ID input is the same as string, more or less. So a GUID is valid, but so is a path traversal payload. And this is like critically important because like one of the things I'll absolutely look for is if I see any requests with an ID coming through as input, that's like a red flag to try out like path traversal, SQL injection, and other like, I would say malicious input like that. So going back to the methodology slide from the second one, again, looking for queries and mutations with ID or string input. I have a strong preference on ID. I think it's just maybe commonly missed that it doesn't need to be a UUID, that it can really be anything as input. We then mapped out the simplest operation possible. So looking for a 404, using that simple fuzz example, right? So it was finding the query mutation, then trying to map out if I can actually cause a 404 or what comes in the response. And then replacing the input variable with directory traversal, right? Verify the path has been fully normalized, so we're looking at the response. Now we're like, all right, absolutely, we have a secondary context opportunity in this case. One common thing I'll do, I don't know if I'm sure many of you do this as well, which is recursively add .. until we get a 400, which is the most common in my experience to determine where the root is of where we're attacking. So once we get a 400 response, that's almost always the root. I mean, there's exceptions to that. but it could also be a 200 or a 503. But either way, we're recursively adding in path traversal to try and figure out or try and map where we're targeting. Also, attempting different encodings for .. Like this is definitely a big one, especially like real-world testing. We're going to run into WAFs. We're going to run into Cloudflare. It may be bypassing, potentially like Cloudflare, or it might just be that the way the encodings are taken on by the BFF, it's important to use like %2f or other versions of path traversal. In terms of like discovery tooling for me as I'm testing, I'm a big fan of Bambatas, which are, I guess if people are familiar, it's custom HTTP filters in Burp Suite. It's a relatively new feature in the past year or so. They can be used to display or highlight interesting information, create custom proxy columns, proxy table columns. This is, I mentioned the QR code here. That's to the Portswigger's Bambatas page. And they have like one example, GraphQL by Gareth Hayes, who wrote that. One that I'll use as an example, like parsing the query value into the proxy table. So again, this is at that QR code. The code is in there. But basically what it'll do is it will take the operation name or whatever is in the request and put it into the proxy table. So you can really quickly pick up, like, for example, halfway down, get wish list is an uncommon query amongst all the other common queries. Because I don't know about you, but typically when I'm testing a GraphQL application, certain queries will like overflow the proxy. So it will be, like get feature flags or send metrics. And being able to see it within the proxy table, I think really like highlights what we're looking for a little bit better. And similar to that, I put a Bambata in there that will highlight or on ID or string in a query or mutation. So as you're walking an application, you'll have like a purple or a red that'll show you, hey, this query or mutation might have the opportunity for secondary context attacks because it's using an ID or a string scalar. Alternatively, bchecks are really good at this. I'd also say like minim proxy highlighting or Kaido highlighting. They're all very good for discovery tooling. A couple years ago, I wrote a tool called Burp Suite Parser Plugin, and I just updated it. But I wrote it for this exact scenario where I see a talk, and like I know how to add it into my methodology in the future, but I'm like curious if I missed it in the past. So this plugin, what it does is it parses burp files from the command line into request or response JSON. So like in this case, we would care more about request JSON. But for example, you could take a Burp Suite file that you had from like February, put out the proxy history as JSON, and parse for just the scalar ID exclamation point, and like really easily find like, hey, is there an opportunity for secondary context attacks like in an old burp file, in an old assessment that I might want to go back and test for. You can also do it like if you have a directory of burp files. Like I know I have a giant directory of all the burp files for years. So you can go back and this will search like every single request that's ever gone through your proxy that might have contained this scalar in case you wanted to try out this attack. So for example, I took that one from February. This was like apparently a GraphQL query that had gone through my proxy. It did have an ID scalar. You can also see it has a string value in there, and it's not, and that's probably, I can guess, an opportunity for secondary context attack because that's an integer. That's not like a real GUID. So it's probably worth trying out like .. on that string. But that's the goal from the tool. Is that you could look back at your old history, you could be able to like look through it and see if, hey, maybe there's an opportunity for this attack. As I was like putting this together, I started researching. I want to see like if other people had talked about this before. I couldn't really find it, which is obviously important for a talk. Like we don't want to, give out old information. But what I did find was in the Apollo GraphQL tutorial forums, the Bug Bounty Reports Explained guy, who's a really great guy, he had been doing one of the GraphQL tutorials and noticed that if you put a path traversal into a query, you could access other people's data. So it was basically like, it was encouraging the incorrect or insecure development of this schema. They were super helpful. They added a call out. They thanked him for it. So, but there is still a call out in the tutorial. So it's vulnerable if you miss the call out, like if the little, like you have to expand into it. But if you wanted to practice, like, hey, I want to create a vulnerable application, it's within here. And the way they recommend mitigating it is, and I'll read it out, to prevent malicious clients from accessing or manipulating the data, use the encode URI component. So they're saying at the router, at the equivalent to the BFF, use encode URI, and it'll prevent the path traversal from occurring. But definitely still worth reading if you want to check it out. I'm a big fan of secure by default. So like thinking back on like ways we've made impact in InfoSec and web app security of the past 10 years, like things like decreases in SQL injection largely based around ORMs and safe by default frameworks. Same with cross-site scripting. We could look at JavaScript frameworks as helping, making that more difficult. In this case, I would say like if we were going to have a secure by default way for this vulnerability, right? If you want to prevent this vulnerability, if you're a developer, if you're a security engineer, I think one of the best ways is through the GraphQL scalars package or its equivalent in other languages. And I'll read out the way to describe it really quickly, but it communicates to users of your schema exactly what they can expect, or at least reduce ambiguity in cases where that's possible. So it's a library of custom GraphQL scalars for creating precise type-safe, that's a repetition, but precise type-safe scalars. All right, so instead of using an ID, it creates a UUID scalar so that when you're creating the schema, you use the UUID scalar, and then validation's happening on GraphQL, and no secondary validation needs to fall into the REST API category. So it's a way of, it's like guardrails for the development. The other thing I would say, the other reason I would like it, and I've seen customers use it as I tested out this, this methodology across a large scale. I saw at least 2 or 3 of our customers use it. And what I really like too is that it draws attention for security review. So if we see a scalar, like let's say there's in that package, there's a scalar called URL. If I see URL in the schema, I know that, hey, we should probably look for like SSRF. We should look for URL-related vulnerabilities. So I think it does a really good job of drawing attention in the threat modeling process. The other thing, and I would just call it out that I like about it, is I'm almost positive you can install it and you don't need to like completely remap your schema right away. You can slowly, it's like a crawl, walk, run, where you can slowly increase the security of the schema. All right, so I definitely ripped through my content here. And we will end up having a few minutes for questions. Hopefully there's some questions. Concluding points on offense, like I largely view modern web application testing as like a game of leads. Like when I head into a web app, I imagine a giant funnel, and I'm just looking for leads or for opportunities for different attacks or different methodologies to try out. I would say for like this specific like attack pattern, if you see GraphQL and a path traversal payload in an input invokes a familiar error, right? So all of those examples where you see that you have control over the request and you can add in a path traversal payload and you get a 404 or a 400 or even better an internal URL in the response. Then you might have unauthorized access to data, business logic vulnerabilities. The one that I unfortunately didn't have time for, but SSRF, definitely had scenarios where if your backend REST API has an open redirect, that just opens the door to SSRF. Because if we can force the server to make a request to some place that we own, then we'll have SSRF, and even more so, because of the hard-coded authorization header, have scenarios where you can actually steal that JOT or steal that hard-coded API key that's been tacked on at the BFF. Had a lot of success working the methodology authenticated as well as unauthenticated. And I'd also add that in for like bug bounty scenarios, because if your job is to like increase the CVSS score, or you're in a scenario where you need to show more impact, often unauthenticated will work pretty well. I would say there's lots of attack surface. Introspection, it helps greatly. Like having to figure out the objects is just not great, whereas having the full schema through introspection is excellent. We could even through the schema look for ID and string, similar to how we're doing the proxy, but just right in the schema itself. There's definitely room for a tool or automation. If you test this out and you like it and you are able to find findings from it, I know there's probably a way that we could be better automating this type of testing. Concluding points for defense, really important security engineer side or developer, ID and string scalars require input validation, right? So it's really important to understand that those can take on any input. It's very liberal in terms of the input it'll take. So we need to have input validation to make sure it matches. So checking for those in source code review and threat modeling. Life can be made a lot easier using a package like GraphQL scalars or developing your own non-default scalars to protect against these types of attacks. And then the second one, and I definitely feel for the security engineers on this one, but avoid hard-coded authorization or authentication at the proxy, at the BFF, at that center point between the untrusted zone and the trusted zone. And the reason I say I feel for them because it's a hard job to track that down, to know if that's in place. But I would definitely say if you're seeing that as part of threat modeling or if you're seeing that as part of conversations where there's potentially hard-coded authentication or authorization, absolutely that's something to dig into more. I would say exploiting the issue is difficult, right? We had to almost always pair together two vulnerabilities in order to exploit it, but it's highly impactful when achieved because there's so much access that it becomes very impactful. Sort of the flip side in my mind of that is there's also lots of opportunity to detect the issue, right? Because we had to do lots of path traversals, we have to like scan around to find the backend REST APIs. So that, on a defender standpoint, is like lots of opportunity to potentially find this out, that it's going on or exploitation is going on. Also, plus-size amounts of like 404, 503 and REST APIs, right? All of those were part of the testing, and absolutely recommended to be looking for those. You know, it could be in Datadog, it could be in some other location where you're tracking errors and responses. All right, so have about 12 minutes left. I would say if you're into like GraphQL testing, like or offensive web app testing, like please come find me. I love talking about this stuff. Like if you've exploited this before, like you know, I'd love to hear about it. Like brainstorm more. Fill out the survey, and then I guess with the time left, if there are any questions regarding the content. All right, nobody? Cool. All right, I appreciate it so much. Thank you so much for coming, and you know, please come find me.